When life leaves you high and dry, I'll be at your door tonight if you need help.
We are first going to graph these two equations by doing an XY table and setting dots on the graph. For the first one, we have x squared plus 1. So, we're gonna plot a couple of points to see where the equation is going. Negative 1, 0, 1, and 2. So, when you have a negative 1, you plug it in this equation, get 1, negative 1 squared, which is 1, plus 1. That gives you 2. When you put a 0 in here, 0 plus 1, so you get a 1. When you put another 1 in here, you get a 2, because it's the same thing. And with a 2 is 2 squared, which is 4, plus 1, 5. So now let's put these dots in. Negative 1 and 2. 0 and 1. 1 and 2. 2 and 5. We can see more or less from this equation, from these dots, where the equation is going. So, this is an equation with a square, so it will be a parabola, something like this. We now have the dots plotted in the graph. The only thing we need to do is check the condition, because here we have an exception. All the dots that are less than 1 will be graphed, and the rest have to be ignored, because x is less than 1. We graphed with an open dot because this is what the condition tells us to do. The open dot is when x is less than 1 and not x is less than or equal to 1. So we have all the dots included from the left of the 1. This is the correct way to graph the equation number 1. And now we're going to put them inside the equation. So negative 1 minus 2, that will give us negative 3. And 0 minus 2 will be negative 2. 1 minus 2 will be 1. No, negative 1. And 2 minus 2 will be 0. So now let's graph. On the negative 1, we have negative 3. 0, negative 2. 1 is negative 1, and 2 is 0. Okay, there we go. Now, we have to look at the condition of this equation. X is greater or equal to 1. So we will start graphing our line from from number 1. So from the x line, number 1 is right here. We'll do something like this. This dot is closed because this includes 1. So now we delete the other 2 dots and our equation is done.
Okay, so now that we have our graph ready and right, we have to find what the question asks us. That is to find the limits of this function. And so here in the first one you have to find the limit of the function as x approaches 1 from the left side. If you have a negative over at top of the number like this, it means from the left side. If it has a positive number over the number, it means from the right side, and if it doesn't have any, it's from both sides. So here we have to find the limit of the function. The function is this one, and this is graphed. And we have to find as x approaches 1 from the left. So here we can see as x approaches 1, not in 1, but just approaches 1, this is going to be about the point here that it's like the limit of. So here we have to now tell like where is the y at when x approaches 1 but doesn't touch 1. So here is going to be basically 2, because here we round. It's going to be a micro infinite number that's going to be like 1.999999. So we round it up to 2. So as x approaches 1 from the left side, y equals 2. So we're going to put it here. That's the answer for the first one. The second one is the same process, but as x approaches 1 from the right side. So it's going to be the same. Okay, so here we're going to approach x from this side, like this. So we go from here, right about here. Here is the limit. Okay, now this one can touch the limit because here it includes it. In this side it was not included because of this symbol. So over here we have the limit at exactly x equals 1. So when the limit is here on the y-axis, it's on -1. So that's the limit, and we're going to put it right here as x approaches. So from this one actually is the most easy one, because it says limit of f of x as x approaches 1 from both sides, because it doesn't have a negative or a positive above it. So here we go to the graph and we just see like x approaches here, y, and over here. So from the left side it goes to +2, and from the right side it goes to -1, as you can see here in both our answers. So this isn't coherent because the limit isn't on the same spot. So by just looking at this and looking that it's not the same limit, you can say that the limit from both sides does not exist. And you write D and E.
There you go, and long after you're gone, gone, gone.
Today we're going to solve a problem of finding the equation of the tangent line to the given function, which the given function is this one. We have to remember some rules that if you have x minus n, if the exponent is minus, you have to move it to the bottom side, it has to be a fraction, or if it's in a square root, the n goes down and the n, once it goes inside, goes on the top. For this type of problems, we have to follow some steps, which the first one is find f prime of x. The second one is find the slope of the tan line, which the slope is m. The third one is find y by substitution in original function, which the original function is that one. And the fourth one is find b with the equation y equals mx plus b. So we're going to start solving the problem, which is f of x equals to 2 over x squared plus x at x equals 2, using the steps. So the first step is to find the derivative of the original function. So we have to rewrite it since we have a fraction, and that means that this exponent is negative. So we rewrite it 2x -2 plus x. Then we can start differentiating, which will be 2 times the -2 pops out times x, and then with the exponents you do -2 minus 1 plus the x turns into a 1. Then 2 times -2 is -4, x, -2 minus -1 is -3, plus 1. Since your exponent is negative, this won't be the final answer, you have to turn it into a fraction. -4, you pass the 3 down, plus 1. This will be your final answer for the first step. Then the second step is find the slope of the tan line. So using the x equals 2, you plug it in, f prime equals 2. You plug in 2 into this equation, so it will be -4, 2, it's 1 over 3 plus 1. 2 equals -4. 2 to the third power is 8 plus 1. F prime of 2 will be -1/2 plus 1. For the final answer of f prime of 2 is +1/2. This will be your m. Now we found m, we have to do the third step, which is find y by substitution in original function. The x equals 2, you substitute in the original one, which is this one. So you do f2 equals 2 squared, plus 2. f2 equals plus 2, and if you simplify, that will be 5/2. So your y will be 5/2. If we write the coordinates, it will be 2, 5/2. So you have your m, you have your y, and for the final step we need to find b. So with this equation, plus b, you plug in the y, which will be 5/2, equals m, 1/2, times your x will be 2, plus b, then x/2, 1/2 times 2 is 1 plus b, then you pass it subtracting, and it will be 5/2 minus 1 is 3/2 equals b. You have your b. And so you have your y, your m, your b, and for the final answer you just plug in the equation y equals 1/2x plus your b, which will be 3/2, and you can also rewrite it like y equals x/2 plus 3/2. This is your final answer. It could be like this or like this.
And long after you're gone, 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 I'll love you long after you're gone, gone.